I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. We are making an attempt to organize most of our videos on YouTube, which are 20,000 in number, in a way so that you can have easy access to a list of videos on the same topics in a well-organized fashion. This website is going to be free for you for all times to come, and I hope that becomes a good resource for students worldwide. Now I'm adding some test papers to this list of videos, and here is a test paper on calculus, derivatives of logarithms and exponential functions. It is for IB students, grade 11. There are 9 questions in this test paper. I'd like you to have a good look at these questions, try them out, and then look into my solution, right? So I think you can see the first 4 now. Here are the other questions, right? So you can just copy these questions, try them out, and then we'll talk about their solution. Okay, so let's begin with the solution from question number 1 itself, which is simplify the following, express all answers in exact form. So we'll, what is this? ln e to the power of 2x minus ln e to the power of x. Well, using the rules, we get ln e to the power of 2x is 2x minus e to the power of x is x. So we get 2x minus x as x. Done. The second one here is 10 to the power of minus 3 log 10. So the base is 10 here, right? So clearly, using our rule, this is equal to minus 3, right? Now, part C is kind of tricky, because of which I have really taken this question. It says x plus y to the power of log to the base 2 pi divided by log to the base 2 of x plus y. How are you going to do this? So there are a lot of tricks involved in this. I'd like you to look at it very clearly, right? So this is x plus y, and the power here is, we have this 1 over, let me write this as an exponent, log to the base 2 of x plus y, right, times log to the base 2 of pi. So as soon as you write in this fashion, you can see that this is kind of reciprocal, right? So we can swap the argument and the variable, right? So we could write this as x plus y to the power of log to the base of x plus y, right, 2 times. Now whenever we have times in exponents, we could also write this as a combination of product, right? So we could write this is to the power, right? So we could also write this as everything to the power of log of 2 pi. Does it make sense to you, right? So what we did was that the first exponent we interchanged and wrote reciprocal rule, right? Let me tell you what we have done here. Change of base formula, right? So if you have log to the a over b, we can change the base to c, for example, right? So we can say log to the base of c of b divided by log to the base c of a, right? We could also change this base to a. So if I do that, we could also write this as log to the base a of b over log to the base, from b, right? So let's write this as log to the base b of b divided by log to the base b of a. Now b of b is 1, right? So we get 1 over log to the base b of a, right? So what you see here is that change of base formula can also be utilized to write the logarithmic function as its reciprocal by swapping, right? So that is the property which I have utilized in this particular case. Now, we could write x plus y to the power of log to the base x plus y 2 as just 2, right? So we get this as 2. And exponent is log to the base 2 of pi. Does make sense to you? Now, since the base is same, we are left with just pi here. So this is equal to pi. So this expression is equal to pi. Does make sense to you? All right. So this is excellent question, and I hope that really helps. Now we'll do part D, which is e to the power of minus 4 ln 2 plus 2 ln 4. So we'll apply the logarithmic rules here. So e minus 4 means we could write this as ln 2 to the power of minus 4, right, plus ln 4 square. Now we get e, plus means we can multiply these, right? So it becomes ln. So when you multiply, you get 2 to the power of minus 4 times 4 square. So which is equals to e to the power of ln. Now I could have written just this number, right? Now we have 2 to the power of minus 4 and 4 square. So 2 to the power of minus 4 is what? Well, you can write this as 4 square over 2 to the power of 4. Okay. So which is e to the power of ln. 4 square is 16 over 2 to the power of 4 is also 16, right? So it is 1, right? So what we get here is e to the power of ln 1. Now ln 1 is 0. So we could write this as e to the power of 0, which is equal to 1. You could do like this. Or at this stage also, you could have written directly, let me rewrite, alternate. So at this stage, from here itself, we could have written this as 4 square divided by 2 to the power of 4, which is equal to 1, right? So we could have got the answer like that also. So I hope that makes sense. Let's move on and take question number 2 now. Log to the base 2 of p is x, log to the base 2 of q is y, log to the base 2 of r is z. Write down log to the base 2 of r square square root q p cube in terms of x, y, and z. Okay, so let's figure out what is p, q, and r from the given expressions. So since we know that log to the base 2 of p equals to x, so p is equal to 2 to the power of x. And then we know that log to the base 2 of q is equal to y. So we can write q is 2 to the power of y. And we also know that log to the base 2 of r is z. So r is equal to 2 to the power of z. Now let's look into the expression, which is log to the base 2 of r square square root of q over cube of p. Okay, so that is log to the base 2 of r square means 2 to the power of 2z, right? Square root of q means square root of this. That means the power becomes half, right? So 2 to the power of, you can write like this, y square root. Okay. And then we have p cube, which is 2 to the power of x. Let me write like this, cube. Okay. Last time I wrote direct. I hope that makes sense, right? So the exponents can now be worked out. We can say log to the base 2 of 2 to the power of, let me rewrite this as 2z. That becomes half of 4, right? So times 2 to the power of 2 over 2 to the power of, sorry, this is not 2 but y, y by 2, y by 2 to the power of half. This is y, not, I took it as 4. Okay, 3x. Okay, so that becomes your expression. So now this is equal to log to the base 2 of, so we can just add them out. So we get 2 to the power of 2z plus y by 2 minus 3x. Right, so which is equal to log to the base 2 of 2 to the power of all this, right? So I'm rewriting, that was not required really. 2z plus y by 2 minus 3x. So because that is the exponent, using the power rule, that is what I get. So this is equals to 2z plus y by 2 minus 3x times log 2 of 2, right? Which is same as 2z plus y by 2 minus 3x. So that becomes your final answer. Clear? Well, this step was unnecessary. However, you could have gone straight from here to there, right? Okay, let's move on and take the next question, which is question number 3. Solve for x expressed in exact form. So we have log to the base 2 of cube root of all this is equal to 2. So we can rewrite this as, in the exponential form, cube root of x squared plus 30x is equal to 2 squared, right? Which is 4. Now we'll cube both sides, so we get x squared, let me write this implies. So this implies plus 30x is equal to 4 cubed, which is equal to 64, right? So now we have a quadratic equation, x squared plus 30x minus 64 is equal to 0. Does it make sense to you? Correct? So that is what you get. Now you can use quadratic formula to find the answer. We have to give it in exact form. So we can write this as x is equal to minus b, which is 30, plus minus b squared, which is 900, minus 4ac, this is negative, so it becomes positive. 4 times this, 4 times 4 is 16, 6, 1, 24, and 1 is 256, divided by 2. So which is equal to minus 30 plus minus square root of, I'm just squeezing it in, we get 6, 5, and 1, 11, 56 over 2. Correct? So that's what you get. Now, if the calculator is allowed, you can actually easily do this calculation. Let me show you what is square root of 1156 is. So we have square root of 1156 equal to, you get 34, right? But if the calculator is not allowed, then how are you going to do it? That is the question. We have different techniques of finding this out. Let me show you a special division method to find the answer, right? We'll do it in short here. So what we do actually is we take this set of numbers like this. You can look into one of my videos of finding this answer. So what goes into 11? 3 times 3, right? So 3 times 3 is 9. We put it here. It's a special division. When you take away 9 from 11, you get 2, bring down 56. And now, twice 3 is 6. We have to put a number same in these two places to get 256. So what could you place? So 4 times 6 is 24. You could place 4 here. So 4 times 4 is 16, and then 4 times 6 24, and we get 256, right? So 34 is the square root of this number. So I'll provide you with a link on how to find square root without calculator, okay? Let's also confirm, if you are allowed with the calculator, you would always do square root of 1156 and get your answer, which is 34, correct? Okay, so let's continue by saying that this is minus 30 plus minus 34 over 2, right? So what we get here is two different solutions. So if I use minus and minus, which is one solution could be, we have two solutions. One is x is equal to minus 64 by 2, which is minus 32. And the other solution is x equals to, when you add this, 4 by 2, which is 2, right? So these are the two solutions. Now, whether both are the solutions or not, how will you figure this out? Well, let's look into the domain of this function. It is x squared plus 30x, right? If I substitute 32 here, do I get a positive number? Well, it is 30 times 32 minus 32, and this is 32 squared. So it is definitely the correct answer, right? It can work, right? Because 32 squared is positive. So we have two solutions in our case, which are x is equals to minus 32 and x is equal to 2. Perfect. You can see that for this domain to be greater than 0, this could be factored as x times x plus 30, right? So the maximum value here is that x is equal to, this is 0 at 0, and that is at minus 30. So we have a maximum value. So this is a parabola, which is like this, right? So you could have anything which is less than minus 15 as minus 30 as your answer, correct? So your domain here is, let me write down the domain. So domain of this function is that x is less than this value of minus 30, or x is greater than 0. So that is your domain. Now, since this solution is within the domain, so both are the correct solution. Does it make sense to you? So that is how we are going to answer this particular question. Now, let's take the next question, which is x log to the base 4 of x cubed plus log to the base 2 of x square root of x is equal to 8. So we'll apply the properties of logarithms, and we could write this as log. Okay, so first let us change the base to 2. So if I change the base to 2, then we get log to the base 2 of x cubed over log to the base 2 of 4, right? The first expression, right? Plus we have log to the base 2 of square root of x equals to 8. Now this is 2 here, right? So we have half of log to the base 2 of x cubed, right? Plus log to the base 2 of square root of x equals to 8. So that is equal to, so we can now combine these terms. So we will go one more step. Log to the base 2 of, that becomes the product, right? So we have x to the power of 3 by 2 times x to the power of half is equal to 8. Right? So we can combine these. So we have x to the power of 3 by 2 plus half is 4 by 2 or square is equal to 2 to the power of 8. Right? So x square is equal to 2 to the power of 8. Now in this particular part, x is greater than 0 is our domain. Correct? So the solution will be x is equal to 2 to the power of 8 by 2, which is 4, and so we get 16 as our answer. Correct? So I'd like you to understand this calculation. So what we did was we first changed the base to 2 and then applied the logarithmic properties to combine and find the solution. So x equals to 16 becomes the solution of this particular question. The next question here is to sketch the graph of y equals to log to the base 2 of x plus 2. Well, let's discuss this graph a bit. We can actually graph it in two methods. We'll use two methods. So first method, which I'm going to do here, is to sketch the graph using transformations. So I'll use transformations. Since basically it means that we need to translate y equals to log to the base 2 of x 2 units left. Correct? So that means, log to the base 2, let me sketch this graph as log to the base 2 of x, right? So the critical points here will be vertical asymptote at x equals to 0. This point will always be at 1, and at 2 we have 1. So these are the things which you are really looking forward to, right? So you can say this is like you can say these 3 points, right? So x to the power of half, this is at half, right? So this point is at half. We have the value minus 2. Right? 2 to the power of minus 1. So we get minus 1 here. Okay. So these are the points. Now what I'm doing here is translating the logarithmic function 2 units left. So the vertical asymptote will now move 2 positions this side. So we have this vertical asymptote. And each point will move 2 units. So this 1 will come at minus 1. This 2 will come at 0, right? So this will be here. So we have a graph which is translated and that is your log to the base 2 of x plus 2. So we have sketched this graph using transformations, correct? The second method which I am going to show you is to get the set of points, right? So we will again work with this function which is log to the base 2 of x plus 2. We can write it in exponential form that 2 to the power of y is equal to x plus 2. Right? So for different values of x, we can calculate the values of y, or for different values of y, we can calculate the values of x, right? So we can say x is equal to 2 to the power of y minus 2. So from here, we can get set of points. The good points to always get here is substituting value of y as 0, right? It could be, the range is any, right? So you could put 0, -1, and 1. So if I substitute y equals to 0, then we get x equals to 2 to the power of 0 minus 2, which is 1 minus 2, or -1. So we get 1 point, which is -1, right? Which is right here, right? -1, right? This point. Now, if I substitute 1 here for y, so we get x equals to 2 to the power of 1 minus 2, which is 0, right? So we have another point here, which is 0, 1. So at 0, the position value is 1. So that is the next point. Do you see that part? Correct? And if I substitute -1 here, in that case, we get the value x equals to 2 to the power of -1 minus 2, so which is half minus 2, right? So which will be 1 minus 4, or -3/2, which is -1.5. Correct? So at -1, we get -1.5. So the value here is, at -1.5, the value of y is -1. So we have moved this point, which was at half, 2 units left. So we get a point here, which is -1.5 minus 1. Do you see that part? So we did the reverse calculation to find the points, writing the function in exponential form. So I hope that makes sense, right? So that is a neat way of writing the logarithmic function and then getting the points. And this is without calculator, right? So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.